Hello again. So in this problem, we have a right regular hexagonal prism, which has side lengths of 4 on the base A, B, C, D, E, F, and a height of 8 units. So the key word is regular, which means that all the side lengths on the base are the same, and they all have a length of 4. And the height of this prism is 8, so that would be the length from like A to A prime. It wants us to find the lateral surface area of the prism. The lateral surface area is the area of all the faces except the two bases. So we want to ignore the areas of the two hexagons. So let's calculate the area of each of the rectangles along the sides. So our lateral area is equal to, well, each of these rectangles has the same dimensions. Because of this regular hexagon, it means all their widths are the same, 4, and the height always has to be the same, that's 8, or the length of the rectangle. So the dimensions of each rectangle are 8 by 4. So 8 times 4. Now, how many rectangles are there? They have the same dimensions, so we can just multiply by the number of rectangles. Well, it's a hexagon, that means there's 6 sides, so we want to multiply by 6. And calculating that out, we get 6 times 8 times 4, which is 192. Now, find the total surface area of each prism. Now, the surface area is just going to include the two bases. Now, when we learned about hexagons way back when, we learned that each regular hexagon can be split up into a set of 6 equilateral triangles. This is way back when we covered, I believe it was when we covered 30, 60, 90 triangles. Each of these triangles is equilateral, meaning they all have the same sides, which must be 4. Now, we had learned about a formula for the area of an equilateral triangle. And that area of an equilateral triangle is the length of the side, x squared, times the square root of 3 over 4. So in this case, one of these equilateral triangles, well, they have a side length of 4. So it'd be 4 squared times the square root of 3 over 4, which would further reduce 4 squared over 4 is just 4. So we have 4 root 3. But that's just the area of each triangle. We want the area of both of the pentagons. So what should we do from there? Well, let's take the area of A, B, C, D, E, F. That would be 6 of the areas of the equilateral triangles put together. So we're going to do 6 times 4 root 3. And we have that 6 times 4 is 24, and square root of 3. So let's calculate the total surface area. Well, it's going to equal the lateral area, all the rectangles, plus the 2 hexagon bases. So we actually want to multiply this by 2, since this is just the area of one of the hexagons. So when we multiply by 2, this becomes 48 root 3. And that is how we get our answer. Again, all these problems amount to is just breaking them down into simpler parts. Finding the surface area and the lateral area is just a matter of finding two-dimensional areas, which we should already be quite familiar with.